In section 3.9, we're going to be talking about the derivatives for exponential and logarithmic functions. And these problems are very similar to the trig functions where you're just going to have to learn the rule. We're back to where we have to memorize things again. Let's look at these four rules. First, let's take the derivative of log. And they may look a little different, but these derivatives of natural log and the derivative of log are actually pretty much exactly the same. I think the best thing I can do is show you an example. So let's look at this derivative. I'm going to start with log. So if I ask you to find the derivative of log base 9 of 5x, this rule says the derivative of log base a of u is 1 over u. So the derivative of log is 1 over 5x times the natural log of the base. So 1 over u, natural log the base, times du dx. This du dx is really just the chain rule. Now we have to multiply by the derivative of the inside, and our inside was 5x, so we get to multiply by 5. So when we make this pretty, we get 5 over 5x, natural log of 9. In this case, I hope you see that we can cancel the 5, so we end up with 1 over x, natural log of 9. So that's the derivative of log base 9 of 5x. This derivative of natural log, it looks a little bit different, the rule, but it's actually the same. Let me show you what I mean. Okay, so again, now I'm going to find the derivative of natural log, and we're going to find the derivative of the natural log of 2x plus 1. So following this rule, the derivative is 1 over u, which is 2x plus 1, times du dx. If we look at this rule, it's 1 over u times du dx. So that would be times 2. But let's look at this. This rule is 1 over u times the natural log of the base. Well, what's the base of natural log? The base of natural log is e. So this is really natural log of e. And I hope you all remember that natural log of e is 1. So even though it looks like that's not there, this part of the rule, it is there. The natural log of e is 1, so we just don't have to worry about it. So this gives me 2 over 2x plus 1. Please do not cancel these 2's. Remember, 2x plus 1 is a quantity. They are married. We cannot cancel those off. Okay, now let's look at the derivative of exponential functions. So this is a derivative of a to the u. Well, here's my example. If I have the derivative of 2 as my base, and notice my variables are my power, so 2 raised to the 3x squared minus 4x. If I follow this rule, our derivative is going to be, keep the whole problem the same. So the rule is keep the exponential times the natural log of the base times du dx. So the derivative of the inside, basically, 6x minus 4. And really, we can't clean that up at all. This we would just keep as 2 3x squared minus 4x times natural log of 2 times 6x minus 4. That's all multiplied together. And again, if you look at the derivative of e, it's keep it the same, the derivative of the inside, or the derivative of the power. What again, natural log the base, the natural log of e, the base e, is going to be 1. So these two derivatives are really the same thing. It's just when we have the natural log of e, it's 1. So my suggestion to you is to remember these two. If you can't remember all 4 of them separately, remember these two. The other important thing that we have to remember is that the derivative of e, that's going to be the only function that is itself when we take the derivative. The derivative of e to the x is e to the x. It's itself. Okay, so let's look at an example. If I ask you to find the derivative of e to the 4x squared plus 1. The derivative is, keep it, leave it alone, e to the 4x squared plus 1 times the derivative of u. The derivative of 4x squared plus 1 would be 8x. Now, of course, I would like that to be made pretty, so I would write it as 8x e to the 4x squared plus 1. So again, this is a problem. These are the rules where you need to learn them. Probably, again, note cards would be a good idea because we're getting down to the wire here, and these are the last of the rules that you'll need to learn. That's not true. We have one other set of rules to learn. So they're just something you need to know. Now let's look at some examples. So problem 1, y equals the natural log of x squared plus 2, and we're asked to find the derivative. So y prime would be, the derivative of natural log is 1 over u du. So 1 over x squared plus 2 times 2x. So we would make that pretty, 2x over x squared plus 2. No canceling, this is a quantity, they're married, done. Problem 2, y equals x natural log of x. Please, please, please tell me that you can see we have a product here. X times the natural log of x. So y prime will be 1 d2. Derivative of natural log is 1 over u du, which would be 1, plus 2 d1, which is 1. So here we have x over x plus natural log of x. Well, I hope you all know that x over x would be 1 plus natural log of x. There's our derivative. Problem 3, y equals the natural log of x squared plus x raised to the 1/3. So when we have a natural log, what are some of the rules that hopefully you remember when it comes to natural log? So hopefully you remember that the rules for natural log are when you have a power, you can bring that out to the front and multiply it. Remember, logs are exponents. So the first thing that I would do here is rewrite this as y equals 1/3 times the natural log of x squared plus x. Now let's find the derivative. Keep the constant, time 1/3 times the derivative of natural log, 1 over u du, 2x plus 1. Now remember, all of this stuff has quantities, so we really have 2x plus 1 divided by 3 times x squared plus x. I would probably simplify that a little bit further and write 2x plus 1 over 3x squared plus 3x. There's our derivative. Problem 4. Now we're to exponential problems. Y equals 3 e to the 4x. So we want to find the derivative. So dy dx equals, 3 is a constant, leave it. The derivative of e is itself, e to the 4x, times du, which is the derivative of 4x, which would be 4. So we would have 12 e to the 4x. Problem 5. Y equals x e cubed minus e to the x. A lot of times people see this and they want to do the product rule, which is fine. You can do it that way. But if you look here, x e to the cubed, e raised to the 3rd power is just a number. So this is just like if we would have y equals 5x. The derivative is 5. So when we find the derivative of this is just going to be e cubed minus the derivative of e to the x times 1. Problem 6, y equals e to the 1/3 x plus natural log of e to the x. There's something goofy going on here. Hopefully, maybe you can figure it out, and I'd like you to try this problem. Number 7, y equals log base 4 of x squared minus 1. So now we're at a regular log. So the derivative is going to be always 1 over u. Then, because it's a regular log, it's times the natural log of the base. So 1 over u times the natural log of the base. Then we multiply the whole thing by the derivative of the inside, which would be 2x. So we clean this up, we get 2x over x squared minus 1 natural log of 4. Remember, we didn't need that natural log in the natural log problems because the natural log of e would be 1. Problem 8, y equals 5 to the x. Now we have a regular exponential problem. So the derivative, y prime is, leave the exponential function alone, keep it, times the natural log of the base, times the derivative of u, which would be 1. So we're finished. Problem 9, y prime equals 3 to the sine x. This is an exponential function, so first you leave it, times the natural log of the base, times the derivative of u, and the derivative of sine is cosine, plus the derivative of 4 to the x, keep it, natural log of 4, the derivative of x is 1. Then minus, I'm going to have to come down here, I wrote too big, minus the derivative of log is going to be 1 over u, times the natural log of the base, then du. Times 2x. So if I clean this up, make this a little bit prettier, I would have 3 sine of x, natural log of 3, cosine of x, plus 4 to the x, natural log of 4, minus 2x over x squared, natural log of 2, and we can cancel this time. If you see this, our x's will cancel. So rewrite that answer. You should have minus 2 over x natural log of 2. Problem 10, please try. 11, please try it. This one's a little goofy. Bonus points if you get it correct, and you can explain it to me. You have to be able to explain it 110% in order to get any kind of bonus point here. No talking amongst yourself. See if you can figure it out on your own.